Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced Stream. I'm Richard at Richard in the MakeCode Forum.
And I'm Thomas at Sparks on the MakeCode Forum.
And today we're starting a new game. So I said on Friday we're going to be starting something new. And then I had an idea, and I've been really excited about it all weekend. So that's what we're going to be doing today. New game. And the idea that I have is not really for a game in so much as it is just a thing. But I think it's going to be fun either way. So Thomas, by the way, does not know what my idea is.
Oh, yeah, I have no idea.
Yeah.
So I'm as excited as you are to find out.
So my idea is MakeCode TV.
Okay.
So I want to make a game that is just a bunch of TV channels that you can just swap between. And there's different things happening on each channel. And there'll be like commercials. One channel might be the news. One might be a sports game you can watch for a while. And you can just flip between all of these random things that are happening. And we'll do like a little static thing as the channel changes, you know, like an old school TV.
Nice. Will it be like quote unquote real time, and that, you know, if you switch away from the channel and switch back to the channel, will it pick up where it left off, or will it?
I want that to happen. And so the first part of this stream is going to be us discussing how we can make that possible. I also would really like it to be that we could synchronize this. Yeah, so there were three things that I kind of wanted to make this happen. One, I want it to be real time, like you said. Two, I want this to run on hardware because I think it'll be fun to have this just running on a hardware device. And I think there's nothing about this idea that can't run on hardware. So, yeah. And three, this is more of a nice to have than anything else. I think it would be really cool if you're using it in the browser, it's synchronized for everybody. So you can just flip through the channels, and whatever you see is going to be whatever someone else sees based off your computer's clock, because we do have ways in MakeCode
time. All right. Wow. I feel like the real-time thing shouldn't be that hard, and yet I'm blanking on how to do it.
Yeah, we'll have to think about it. So mostly I think it's just going to be a lot of fun to make a bunch of dumb commercials and things.
True. That's fair.
So, yeah, so this will probably be something that we work on for a while. But first, we need to talk about like how to do this real time. So what is the problem with this real time thing? Basically, we need some way to have something running. Well, I mean, kind of the scope of the problem is we want to make it so that if you are on channel A and 5 seconds have elapsed, then you go to channel B, 5 more seconds happen, then you go back to channel A, you'll be at 0.10 seconds. You know, time kept running while you were on channel B. And so there's like two ways you can kind of do this, right? So one is to just have all the channels always running simultaneously, but only one drawing to screen, right? So that's the easy way to do it, but is bad for performance. Because it's very easy to just have all of these sprites running and then just set all of them invisible except for the one that's currently running. And I want this to run on hardware, so this might not be the best way to do it, but it might be the only way that we can do it. And it might not be that bad on hardware. I mean, it depends on how many channels we have going simultaneously in it. So
yeah, I guess you just assign each sprite a channel. And
yeah. And then option 2 is we just have some way of, given a time, just, you know, skipping forward that amount of time in whatever scene we have playing.
Yeah.
Right. Which we're kind of gonna, if we want to have this synchronized for different time, we're gonna kind of need that.
You need to do things with like a delta time for sure, like you would normally with physics. That wouldn't work for, you know, just passing in a delta time of 2 minutes is just going to break stuff, right?
Oh yeah, for sure. No, it's going to have to be something more than that. It's like we'll have to make like special blocks or something where we can just kind of like
really quickly try and simulate run your physics update at some super fast speed. before you draw anything.
Well, so like we're not talking about things that are like interactive here, right?
Yeah.
These are just going to be things that are like running and then channels you can swap between. So that's a partial benefit for us.
Yeah. I don't think we want to do like, I assume we're going to want to use sprites and stuff. If everything was just an animation, it's easy because you index into the appropriate animation frame based on the time.
Yeah. That'll never run on hardware because that will be so many images that we would have to fit on. We definitely want to have sprites that are going to be like moving and stuff.
If there's a way to translate that idea into something that works with sprites, but I don't have anything yet.
Yeah, I think so if we kind of break it down into like what are the things that we will want to do for these commercials, I think that, or commercials or whatever it is going on, we're definitely going to have sprites that move around and text appearing on screen.
Yeah, text or talking. Yeah.
Right.
Some sounds.
So, yeah, sound as well. So if we make blocks that have like a move thing, it's really easy for us to make a move block where we can say like, this is the current time, just like do this up until the current time and like skip forward, right?
Yeah.
Like we know how long a move operation takes to get from point A to point B. So we can just fast forward that. So I guess the way that we would do this is we would want to make some blocks that are kind of our core operations, moving sprites, playing animations, and making text appear on screen and playing sound that we can then basically skip forward. The only tough one of these, I think, is sound, which we'll just kind of have to cheat on.
Yeah, I mean, you could make it just kind of a side effect to some of the other blocks if needed. Although then you'd have to have separate blocks for every. Yeah, never mind. That's a bad idea.
Yeah, but I think that this other thing is this other idea is definitely possible. It's also would be kind of nice because it means we could also. I mean, this is what we would do. We would be able to like fast forward and stuff as we go. 1 to 2. I don't know what we would use that for, but it's kind of a fun thing where you could like run everything in double time.
Yeah, cool if you could rewind.
Yeah,
that might be a little harder.
Oh, you want to have MakeCode DVR where we can.
I'm gonna record my favorite channel. Go back and watch it later.
It would be kind of funny to have a TV guide, and I don't think we're gonna have that many channels, but have them all like laid out that you can kind of go between. Hi, Belangus.
Hi, Wolf as well.
Oh yes. Sorry. For some reason, StreamYard never likes to show me the first comment that gets posted.
Oh, interesting.
Yeah, no, it's weird. Okay, so I've got.
It's just always supposed to comment first. So then.
Yeah. Also, hi, Admiral Fish. I always have 2 computers going, right? I have the computer where I am streaming and everything, and then I have like my computer where I'm like managing the stream. And for some reason, on the one where I'm managing the stream, it always skips the first comment. So someone always says hello, and I never say hello to them because I don't notice it. Anyway, sorry. This is all back stuff. Okay, so let's get to doing some coding stuff. So I think that we can kind of start by, we're going to be making an extension first. So for folks who haven't seen, we're doing a stupid thing where we're going to make a TV channel. But we need to have a bunch of blocks that can basically run for a certain amount of time and then like pick up after that like delta time has elapsed. So if we go into JavaScript, we are going to create a custom.ts, and let's start with the easiest one of these. Which is going to be move sprite.
Alrighty.
So this will take in a sprite. This will take in a X, a Y, and a speed. And with this, we should be able to basically, I think what we're going to do is behind the scenes, we're going to have like a time that we are keeping track of, right? So this time is going to be a number. It's going to be like milliseconds since all of this stuff started. Every frame, we're going to be incrementing this time. And when we want to run a scene, we're just going to execute all of these things. So these functions that we're making, they're going to pause until they're completed. But we're going to make it so that when we are executing a scene, we will just keep going until the like scene time is equal to the time, the global time that we have, and then we'll like just pick up from there. Does that make sense?
I think so. At a high level, yes.
Yes, I think I'm also kind of like I'm just coming up with this in my head as I'm saying it. So, okay, so let's actually do. We're gonna have a scene state, or we'll just call this state. And we're gonna have a function. Well, let me go ahead and add my favorite extension that nobody knows gets added to all of their extensions, which is Ricnal/arcade extension util. There you go. This is an extension that is just for people who write extensions. And all it lets you do is I'm going to create this function, which is going to be called create state. Return new state, like that. And then I make a function called underscore state. It's going to return underscore underscore util.get state create state. There we go. So what is this doing? Well, so you might know that I see you now, Woof Woof. You don't have to worry. So you might know that MakeCode has a concept of scenes. And when you have scenes that are like getting added on top of another, you want to have different state for them because you want each one to be treated as a new game. So I made this extension because I was writing the same code every time I create a new extension, which is you create a stack of these different states that you keep track of. And all this extension does is it has this get state function, which if you pass in a factory function for creating your state, it will just automatically work with scenes. And this is less code than I had to write before to always maintain all of this. So that's what that is. It is only useful if you're writing an extension. Do not add it to your projects where you're doing blocks or whatever, because there are no blocks. All right. So inside here, we're going to go ahead and have our time. We're going to go ahead and do constructor this dot time equals 0. And we're going to immediately register an update handler. Belanga says text in MakeCode Arcade. What is this? Some sort of programming language? Yeah. Blocks are programming language too, though. I mean, come on.
You're just different ways of telling the computer what to do.
Mm-hmm.
It all works.
All right. So inside here, we want to keep track of how much time has elapsed. So normally if you're doing this in MakeCode, you just want to do game.runtime. Right? So this will return the number of milliseconds since the game has started. But because we're kind of like doing our own custom time things here, we're just going to do it every time a frame happens. And so there is actually a way to get the amount of time since the last frame has elapsed, which is by going to game.currentScene.eventContext.deltaTime millis. So this thing right here, this is always equal to the number of milliseconds since the last frame ran. So by adding this to our time on each update, we can keep this time that we need. The benefit of doing this with a non-update as well, actually, I don't know if game.runtime, I think game.runtime does actually keep the scene stack.
Yeah, I wasn't sure what the benefit was this over that was, but
yeah, I think the benefit here is just going to be that we're going to have to do our own custom time stuff, I think, and I think we might end up running into problems if we use game.runtime. But I do think game.runtime does actually take care of the scene stack, but well, whatever. Doesn't matter. Wolfwolf says, I knew about that extension. Cool. All right. Okay, cool. So we got a time. We're incrementing it. We have the state. We're going to go ahead and implement this move sprite now. So I think the first thing we're going to need is export function create scene. And this is going to take in a handler, which is going to run the scene code. All right. And we're going to go ahead and put a class here, which is going to be called scene. I'm calling it scene because that is the thing that makes the most sense, but I'm worrying if that's going to get confusing for everybody because I'm also talking about arcade scenes.
I'm trying to think of an appropriate synonym. Channel's a little too specific.
Well, let's do channel. Let's still, at least it's not a word we're using.
Sure.
All right. And in here, we're going to have a channel array, which we're going to go ahead and set to this.channel equals that. And when we create a channel, it's going to add itself. State.channel.push this. All right. So we can keep track of all of these guys. We're also going to put an update in here. And inside here, we're going to go ahead and go for const channel of this dot channel dot update. Great. All right. When we create a channel, it's going to take in this handler. So we're going to go ahead and say handler. And in here, we're going to do see that. It's weird. I feel like I do this constructor side effect thing a lot in arcade. And then every time I have to do this, I get really grossed out. But whatever. Well, it doesn't matter.
It didn't raise any red flags on my end, but no.
All right. So in here, we're going to have a current channel. And we're going to go ahead and say channel index. And we're just going to set channel index to be 0. We will assume that a channel has been defined. And inside of this current channel, we're going to go ahead and do return this dot channel of this dot channel index. Great. Okay. So why are we structuring all of this way? Well, we have this channel class, which has this handler that's going to be running. So when we start running the channel, we're going to evoke this handler. Inside that handler, that's where like move sprites and show text and play sound and all of that stuff are going to be running. Like we're going to make sure all those functions are called within this kind of like handler that gets passed in. And the idea is that all of these are going to be done by basically calling state.currentChannel.move sprite x, y, speed. So we're going to basically implement all of these functions that we're defining here on our channel as well. And a channel is going to have an elapsed time. And we're going to have a change channel function, basically. So let's go ahead and have a start here. And inside here, we're going to say this dot elapsed time equals 0. And every time we do one of these operations, we're going to increment this elapsed time by however much time the operation took. And we're going to say, okay, when this operation has finished, will the elapsed time be greater than or equal to whatever the current time is on the global state? And if it's less than that time, then we will just immediately do it and move on to the next operation. So that's how we're going to like skip forward through all these things.
So the implication here is that when you switch to a new channel, behind the scenes, it's rerunning everything from the beginning.
Yes. Except it's not actually running. We're just going to be, immediately updating the state on everything.
Skipping. Yeah.
So this is, I think, the most efficient way to do it. I mean, it's a little chunky for when you first start the scene, but I feel like it's, unless we're doing something really complicated, all that stuff is just going to run instantly and it's not going to be a problem.
Yeah. The alternative you'd have to save the state of every channel.
Yeah.
At least a static state, even if you're not running it. So this is probably better.
And each channel is not going to be just showing one thing on a loop, probably. Like, we will probably have, like, a show and then a break for commercials where we play some dumb commercials that we write in 30 seconds. And then back to the thing. So we'll need some way of indexing to where we are in the schedule and then basically starting from there. But I think if we have, like, each channel can have a schedule and then it can just, like, do an index into it based off of the amount of time elapsed, which won't take very long. And then it can start that scene with the amount of offset that it has, basically.
Yeah, that makes sense.
Yeah. Okay. It might be more appropriate to actually call this show.
Yeah, it's kind of like a...
Yeah.
Yeah.
Well, we can worry about that later. All right. So what we're going to do when we call start is we're going to set this.elapsed time equals 0. And we're going to go ahead and call this.handler, which I realize now we did not actually store. There we go. Now,
still weirds me out when you can do that.
What, the public thing in the constructor?
Inside the constructor. Yeah.
Oh, it's great. That's one of my favorite TypeScript features right there.
Yeah.
The thing that still amazes me every time I see it done, because I didn't even know it existed until we started working with the modern Blockly code base, and they use it all over the place, is when you do override. And I was like, that's so nice. I wish this had always been there. And so now I do it all over the place. But every single time I'm like, I'm using a brand new thing. I'm so cool.
Yeah, I guess override, maybe that's been around in C# for a while. You need it. Yeah. And I think they might have added that constructor public thing in C#, but I'm not 100% sure. Yeah.
The override thing, by the way, you cannot use in MakeCode because our TypeScript's too old.
Oh. It wouldn't be overriding anything here, right?
No. Here it wouldn't be overriding anything.
Okay. Yeah.
It's not even a keyword in this version of TypeScript.
Oh, I see what you mean.
All right. Okay, so let's do move sprite because that's easy enough to do. We want to calculate the amount of time this will take to elapse. So we're going to go ahead and we have our sprite's current location. We have the location we're going to. We have the speed. So the amount of time is equal to I'm going to do duration equals let's see. It will be distance. So I'm going to add sprite utils. Because I don't want to code up. What am I just typing sprite utils for? Because I don't want to code up the distance formula. So we'll do distance equals, well, I guess first we'll do endpoint equals sprite utils dot position XY. Then we're going to do distance equals sprite utils dot distance between sprite and endpoint. And then we're going to do angle equals sprite utils dot angle from sprite to endpoint. Okay. So we have the distance in pixels. We have the speed, which is in pixels per second. So the amount of time is going to be the distance divided by the speed times 1000. So whenever I'm trying to do conversions, the thing I always do, which works out, even though it doesn't seem like it should, is just make the units match up, right? So I have like time and I have, pixels divided by time. So wait, sorry, I have pixels and I have pixels divided by time, and I want to get time out of it. Then you have to divide pixels by pixels divided by time, and you just get time up top. So this is going to be what I just said, which I've already forgotten. Distance divided by speed, and then we want to multiply this by 1,000 because we wanted in milliseconds. There you go. Okay, so the current time is equal to state dot time. So we're going to say if this dot elapsed time plus time is less than current time, then we are going to do sprite.x equals x, sprite.y equals y, return, because it's already done. Otherwise, we have two cases. One, either this will, our current time is equal to whatever the current time is on the scene, right? So we've already caught up. So in that case, we're just going to start a move operation. The other thing that could be happening is we are partially through our move.
Right.
So we're going to go ahead and say const elapsed time equals, and we're going to do state. Oh, we already have current time. Current time minus this dot elapsed time. All right, so this is the amount of time that has elapsed in our current operation. So if this is, if elapsed time equals 0, well, I guess we can just treat it the same way either way. So we're going to say const progress equals elapsed time divided by our time. Okay, so this gives us a number between 0 and 1, which represents how far we are through this operation. And we're just going to make a function which will do a move sprite. It'll take in a start location and an end location, and given the amount of progress, that number between 0 and 1, we will move ourselves that far along.
Yep.
In our thing.
It's a lerp, as they say, I think.
What?
A linear interpolation is what I think we're doing.
I've never heard that before. Lerp, did you say?
Lerp. Lerp.
I like it.
Yeah.
All right.
That's what that is. I should double check that.
Okay, so we're going to do a move sprite core function. This is going to take in a sprite. This is going to take in a start, which is going to be of type sprite utils.position. It's going to take in an end, which is going to be sprite utils.position. And it's going to take in a progress, which is going to be a number between 0 and 1. Generally, whenever I have the word progress as a variable name, I'm always using it to refer to a number between 0 and 1. That is just like what I do.
Makes sense.
So to make this happen, what we're going to do is sprite.x equals start.x plus end.x minus start.x times progress. Easy enough. And sprite.y, same idea. And there we go. So all we need to do is call this every frame until we have basically reached the end. So I think what we can do here is we can now kind of like generalize this. So the thing is, we're calling this move sprite. This is going to start our operation. And we need to, every time this channel updates, we want to continue this operation until we've like gone past the thing. So I think what we're going to do here is we're going to make another class. And we're going to call this is a very C-sharpy thing, task.
Yeah.
And so this is going to have a constructor. It's going to take in start time and do duration, and then do task, which is going to be a number which takes in progress and then returns void. And we want these all to be stored. So we're going to go ahead and public. By the way, everyone gets impressed on stream whenever I do this. If you want to do multi-cursor stuff in Monaco, if you press Control and Alt and hold those, and then press up, down on your keyboard, you can select multiple lines at once, which is real nifty, because then, you know, you can do whatever. But if you want to add like public to every line, it's very nice. I do this all the time. All right. And that's all we need to do in task. We'll have an update function. This is going to have so we're going to take in the delta time. So we're going to get that just like we did before. And we're going to figure out, let's see, I guess what we could actually do is have a, I guess this update, instead of doing this delta time thing that we're doing here, this update is going to take in a current time. And then in here, we're going to say elapsed equals current time minus this dot start time, progress equals elapsed divided by duration, this dot duration. We're going to clamp this. So we're going to do math.constrain, and we want to clamp this between 0 and 1. It's not actually going to go negative, shouldn't at least, but we want it to be, we don't want this to go beyond the end of our operation. And then we're going to call this dot do task progress, like that. And then last thing we're going to put in here is finished, which is going to take in a current time. And all that's going to do is return current time minus this dot start time greater than this dot duration. Greater than or equal to, I guess. There you go. Cool. Now, in our channel, we're going to have a current task. And inside of our update, we are going to say if this dot current task, this dot current task dot update, and we're going to pass in state dot time, like that. And then we're going to say if this dot current task dot is finished. Let's just, I guess, put then we're going to say this dot current task equals undefined. Back over here, we are going to say, okay, this dot current task equals new task is going to take in our start time, which is going to be equal to this dot elapsed time, our duration, which is going to be equal to this time thing that we've currently figured out, and then our do task, which is going to be something that takes in progress, and we're going to call move sprite core. This is going to take in our sprite. This is going to take in our start position. So let's go ahead and say const start point equals sprite utils dot pause sprite dot x sprite dot y, like that. So start point, end point, progress, and there we go. Now we just want to do pause until not this dot current task. All right, so this will pause our handler so that it doesn't advance to the next task until this one has completed. This one is going to be updated inside of this update function. And this is all assuming that we're not going to call this again while this is running, right?
So this would pause any code that's underneath this block, but not necessarily code in other, mouth blocks that's running. Is that the idea?
Yeah, basically. Yeah, so there we go. Okay, so we should now... this should do it, I guess. So what are the other ones we wanted? We want move sprite, and then we want export
show
function.
Text.
Yeah, show text. And this is going to take in, what should this take in? So we want to show text. We're going to be using fancy text for this because that's what, we do. And fancy text has a bunch of fonts and stuff like this, stuff like that. So that's going to turn into a monster block.
Should it just take a text sprite?
That's what.
Oh, but then you have to create the sprite to call it, which might be
no. I think we can create the sprite and make it invisible, and then in here we will make it visible, and there are things on the text sprite for doing animating.
I see. That's fine. It just means all the text sprites we ever need will always exist, but so it's just text sprites. Maybe that's fine.
No, we're going to... So whenever we create these sprites, they're going to get created in the top of this handler. Right?
Oh, that's a good point. Yeah. So it'll only happen when you switch to the...
Yeah, or we could even create it. I mean, we could create the text sprite and then immediately call animate text on it, right?
Yeah, makes sense. Cool.
And when we stop running the handler, I guess what we're going to do is we're also going to have like a canceled thing right here on this channel. And if it's canceled, all the operations are just going to do nothing. And then we can immediately get to the end.
Yeah.
Okay, so this is going to take in a sprite. We are going to assume this is a text sprite. And this is going to take in a duration and a left number, top number. This is our position. So the duration, I think we want to take in like two things maybe, which is going to be like speed and duration and like pause. So this is going to be the speed at which each character prints out. So like the typewriter style. And then pause is going to be how long to pause at the end with all of the text. And then go to the next one,
Yeah. Yep.
And then this is obviously just the position. Let's put where we put the speed and pause because that just feels right for me. So this speed will be in characters per second. This pause will be in milliseconds. And then left and top, obviously that's pixels. So let's go ahead and copy this function's signature. We're going to go up to here. And we are going to actually implement it in here just like we did for the other thing. So let's go ahead and call it. We're going to go state.currentChannel dot show text and take in sprite left top speed pause. All right, so this has all been very dry because we've just been talking about this stuff without actually doing anything. Let's call this MakeCode TV, by the way.
Yeah.
So we're going to go ahead and create a test scene now that we have like two things kind of defined. We'll just do this in TypeScript so that we can see our code running.
Sounds good.
Yeah.
I'm so curious to see if this is going to work for Stray.
I'm with you. Okay. So we're going to do custom.createChannel, which is going to take in a handler. We're going to create two sprites. So wait, what is this? Why is this unhappy with me? Oh, okay. I think I did something wrong here. Where are you? Create channel. Yeah, I do this sometimes. Void.
Oh, yeah.
Open curly, close curly is a type, as well as creating an object or creating a block. So I sometimes write that out when I'm writing out the type definition, but it should be void because this means return an object.
Mm.
Right.
Oh, I see. It's just doing like one of those, yeah, on the fly types.
Mm-hmm. So we're going to go ahead and say const duck equals sprites. What am I doing? Equals sprites dot create. We're going to pass in an image here, which is going to be sprites dot, let's see, duck dot, okay, which of these is the normal duck? I think it's duck 3.
I was going to say the same thing.
Yeah.
I don't actually know. I didn't realize you could reference the sprites this way.
Yeah, so all of the built-in sprites actually have qualified names, which don't get included in your program unless you reference them. So they don't like make the code bigger, but you can use this when you're in text. Wolf says, I also use the 0 to 1 thing. It makes multiplying values to get to the in between easy. Yeah. Wolf is always like 10 minutes behind us. So
he'll catch up eventually.
Yeah, he'll think that's very funny when in 10 minutes. Okay, so we'll make a duck and we'll make a dog. So this is sprites.builtin.dog 0, I think is just normal dog. And we're going to give these both kinds of sprite kind.player. I don't know. We're going to need to clean these all up at the end of the scene. So sprite kind is going to super matter because we're not really doing any events here, but we want to actually have something so we can call destroy all at the end. All right, so we want to have, we're going to set the duck's position. So we're going to set duck.right equals 0. And Wolf says, someone called me now, so I'm super behind. Fair enough. And we're going to set dog.left equals screen.width. All right, so both our guys are off screen. And we're going to go ahead and do custom.moveSprite duck. We want to move just like in. Then we're going to have dog move in. This is good because I think these sprites actually face opposite directions. So we'll have duck move in. We'll have dog move in. And then we're going to have them say some text. It's going to be our wonderful test scene.
Sounds great.
So we want our x here to be equal to, I don't know, 80 minus 20, 60. Y should just be halfway through the screen, so that's also 60. Speed is going to be 100. Then we're going to go ahead and move our dog. Dog is going to move to 80 plus 20 is 100. 60, 100. All right. Now we have our channel. I think we need to, inside of custom.ts, we're already calling updates. Will this just start?
Do we have to?
No, we need to call start on the channel.
Yeah. What actually calls update as well?
Update gets called right here. I realize now that gets called for all, when really this should only be called for the current channel. So
yeah,
this dot current channel dot update like that, and then update gets called in here where this current task is defined. This won't actually get defined until we call start. So we're going to go ahead and do export function change channel index. And then we're going to go ahead and say state.current channel equals channel index. Oh, wait.
Channels at channel index or something to that effect.
I think it's...
Oh, okay. You have channel index.
Yeah, channel index. So state.channel index equals channel index. And then we want to do state.current channel.start. We're going to have to change all of this once we have more than one channel, but for now, this will at least make it so our code runs. Okay, I think this should go. Nope. We didn't call change channel. Okay, that's on me.
Oh yeah, we didn't call it. I think that's a quarter or something.
That is a quarter. You're right. So was mistyping my own extension earlier.
Oh.
There you go. Duck. Okay, dog. You were not supposed to teleport.
The dog doesn't know that it's supposed. I think so. Both of them, I think they're supposed to start at 0, and so the dog thinks that it should have come in already by the time the duck comes in. We need a way to tell the dog.
Yes.
Yeah. It's like
so we have. We're not changing our elapsed time, right? That's the thing that's wrong here.
That would also be wrong, but I don't know if that's.
I think that's the thing, because we are using the elapsed time in this function, right? For whatever the current time is.
Oh, okay.
Wolfo says, I do think that's very funny, LMAO. So I wasn't checking, but I do think that's about 10 minutes behind.
Seems about right. Let's see. 5 minutes.
Okay. So we're going to go ahead and say, or I guess every time we complete a task, we should be advancing our time. So we should say here, this dot elapsed time plus equals time, like that.
Yeah.
And we should be doing the same thing in here as well, in this short circuit thing. Okay, so I think, there we go. Duck comes in, dot comes in.
Wow. Look at that.
Yep. And we don't really have a way to test the changing channels just yet because we only have one channel.
Yeah.
But we can, I don't know. Should we just define another channel right now so that we can switch between them?
It wouldn't take that long to.
Yeah, I don't think it would.
You just got to define it.
So let's go ahead and define another channel. Who's going to be the stars of this channel?
I like the ghost.
Okay, so Skelly.
Anchor, okay, Skelly. That works.
So we're going to call this, this is sprites.castle.skelly front. The other thing is you have to know.
This is a little, that's.
You have to know the qualified names, which I just happen to know because, I put these all here. But we have no expectation, by the way, that anyone is going to use these. Use the image editor, use the gallery. Don't do what I'm doing. I'm just being lazy.
The arcane ways of the MakeCode power user.
Okay, so I just want to have this thing constantly running. So we're just going to define like a bunch of animations for Skelly of just moving. Just something so we can like see that it has elapsed. So I think we're just going to have Skelly move in a spiral around the screen.
Yeah. Maybe nice and slow, so it's not too, we don't have to rush.
Yeah. The point is, the channel we're actually testing with is the duck dog channel. That's going to have like stuff happening. But we need something that we can switch to and actually make sure that it has progressed. And then switch back.
Yeah.
So, all right. We're going to do custom.moveSprite. Or I guess we can just do let finished equals false. Or let's just do a while true, I guess. While true. We are going to say let direction equal 1. We're going to start Skelly up in the top left. And we're going to move over, and then subtract 16 from the distance we travel. And then over, subtract 32 from the distance we travel, so on and so forth until we get to the center.
Yep.
So we're going to go ahead and say let turns equal 0. So we're going to call a turn every time we go 4. So we're going to say if direction equals 1. Then we're going to do skelly, or we're going to do custom dot move sprite. And this is going to be skelly dot x plus screen dot width minus skelly dot width times turns plus 1. There's no reason I need to make this us doing a spiral. I just want to.
Could just be a square, but a spiral will be nice too.
It'll be fun. I promise. It'll be worth it, everybody. Okay, wait. So this should be like that. And then get rid of that extra parentheses. I guess we don't even need to do this direction business. We can just do this 4 moves, and then increment turns. All right. So this is moving us to the right. Next one, we want skelly.x to stay the same. We want skelly.y to be plus screen.height minus skelly.height times turns plus 1, like that. Then for this one, we want this to be minus this. And then for this last one, we want this to be the same, but we want to, let's see. So we move the full distance, less, even less, do.
So we actually kind of want to increment turns 1 above.
Yes.
Or just do it manually. But
we always want to increment turns before we move up.
Yeah.
And then we want this to be this. I also think it should be maybe turns times 2.
Turns time. Oh, because you're going to be starting from less of a...
Yeah. Well, this is actually complicated.
Yeah.
Okay, we're going to do this the easy way instead. I was like trying to be clever by having 1 variable. All right. So when I say the easy way to do this, what I mean is you just keep track of 4 variables. Every time you move, you subtract something from that, and then you just keep doing that as you move around. Nice and easy. And then you know you're done when min x is less than max x, or greater than max x, and min y is greater than max y.
Yeah.
All right. So we're going to move to max x minus skelly dot width divided by 2, I guess. And we want to keep our y the same. And then we do max x minus equals skelly dot width. That. And we're just going to keep doing this. So this will be skelly.x. This will be skelly.y. Oh, sorry. This will be max y minus skelly.height divided by 2. Don't actually need parentheses here, but it makes me feel better. And then this will be max y minus skelly.height. And then we're going to go ahead and do x again. So let me actually grab this. No, undo. Let's see, Control V. So now we're going to move to min x plus this. And then we're going to do min x plus equal skelly.width. And then we're going to do y, which is going to be skelly.x. This is going to be max y. Sorry, this will be min y plus skelly.height divided by 2. And then we want to add to this. And so for this, we actually want our min y to start out at skelly dot height, right? Because we skipped the first one.
Yes, makes sense.
Yeah. And then now out here at the end, we just say if max x is less than or equals min x, or max y is less than or equal to min y, return. And there we go. All right.
Yeah.
That works. Let's change to channel 1. Look at him go.
Oh.
All right. Well, that didn't work perfectly, but he's going in a spiral.
Yeah.
Good enough. Moving too fast, though, so we want him to move nice and slow.
Yeah.
5. There you go. That should be good enough for testing.
That should. Yeah.
Okay. So there's Skelly going on his merry way. And then down at the bottom here, we're going to do skelly.destroy. Wait, why is this?
Oh,
right. We did a return here. Okay, so we'll just do break instead. And then right here, we'll do skelly.destroy.
Could even just put that conditional inside the while condition, but that's
we
fine.
Totally could, yes.
You have to invert it, but
yeah, I know. De Morgan's law.
Hmm.
There we go. Cool. All right, so that's our other test channel. And we're going to go ahead and say let current channel equal 0 controller dot a dot on event controller button event dot pressed. Then we're going to do if current channel equals 0 custom dot change channel 1 and do current channel equals 1 else custom dot change channel 0 current channel equals 0, and then down here we start our initial one, which is 0. So now we have those going, and then up here we can see that our Skelly did not start at the top left. I'm gonna wait. There we go. Yeah, so Skelly's over here, not at the top left.
Beautiful.
Yeah. Now, obviously, we still have our sprites right here. And right now, we are doing nothing to actually stop the other one. So we need to do that. We're going to go ahead and go into here and do duck.destroy. I don't know why it keeps like not coming up with the like, why is destroy not in the IntelliSense right now?
That's kind of weird.
Yeah. We're going to go ahead and clean up our sprites right here. Now, this still isn't going to make it work. So when I change channels, you can see duck is still there. That's because this one is now just pausing forever because we're no longer calling update. We need to make it so that we start that fiber up again. So we want to dispose of whatever the current task is and then just have it like a canceled thing so that we know to skip the rest of the tests.
So, arguably on the sprite, we would want to destroy all the sprites and the cancel as well, right?
Right. Well, the cancel, if we do the canceled thing, it's all going to immediately run and then destroy the sprites automatically. You know, because we're doing that at the bottom of our handler.
Oh, gotcha. Yeah, that makes sense.
Okay, so we're gonna go ahead and say canceled Boolean. Inside of here, we're going to say this dot canceled equals false. We want to do this above where we call our handler. And then in here, we're going to say if this dot canceled, return. And then we're going to do the same thing right here. No need to mess with the time because this should all just, finish. And we're going to put in a cancel. And that's going to say this dot cancel equals true. And this dot current task equals undefined. All right. So when we change channel, we're going to go ahead and say state dot current channel dot cancel. Like that. And this isn't going to work quite perfectly, but it'll be good enough for now. So now when we do this, if I press A, there we go. Our sprites went away, and now we have Skelly over here. Press A again. Huh.
It's weird.
It's weird. Wonder what's going on here. Let's see, current channel equals 0. Then we do current channel equals 1. Custom chain channel 0. Current channel equals 0. Oh, right. Wait, no, I don't know what's happening. I was like, I think I know what's happening, but I don't actually. I was thinking that what was happening was we had the scene running, the scene finished, and then we started up the scene again, which just immediately ran this code and destroyed it. Right?
Hmm.
But I think we're not actually doing it fast enough for that to be a concern. And also, I don't know why Skelly's getting stuck here. We did destroy Skelly at the end of that scene, right?
Yep.
And this is definitely going to run. This will definitely terminate even after we do this. Okay, so something weird is happening. Let's see if we can figure it out. We're going to put a breakpoint right here. Just to make sure I'm not being really stupid. So we press A, current channel equals 0, step, change channel to 1, and then, I see what's happening. Okay. So what we're doing right now is when we call this change channel, this is calling that handler, which is not going to return until this code has finished running, which when we cancel it, that means that it will immediately stop. But I think that means that it's getting a little confused. What we need to do is when we change the channel, we need to run our handler in a separate fiber.
Mm.
When I say fiber, I mean thread, and we call them fibers in MakeCode, but they're just threads. All right. We're also out of time, so we should call it for today. I got too distracted because I'm having fun coding this. Join us on Wednesday, where we're going to do the text and also get this stuff figured out. And then we can actually start doing some commercial things on Friday, because that'll be fun. So we're going to be doing more boilerplate stuff on Wednesday, but on Friday we'll be over to fun stuff. Remember, we have a mini game jam going on right now. We're going to be playing all those games at the end of next week, I believe. So make sure that you get your game submissions in. Wait, 30 days has September, April, June, and November. Yes. All right.
Yeah, you're right. Yeah.
And I'm Richard at Richard on the MakeCode Forum.
I'm Thomas at Sparks on the MakeCode Forum.
And we'll see you later. Bye.